Hello, everyone, and thanks for being here. It's amazing to see you all there. I'm so sorry I couldn't attend in person, but I'm anyway super happy to see that you could actually join, and that's amazing after all the time we spent divided. But let's get started. So, my name is Rob. I'm a senior Android engineer at the New York Times, and today I would love to talk to you about the importance of being tested as soon as slides actually work. Yay, it looks like they work. So, to start, what is testing about? Because I know that we all test and we all write amazing tests. No, I lie, I don't write amazing tests, but don't tell that around because I'm supposed to be the one writing the good tests. So, to answer this question, well, we have two main points that we can actually highlight of these practices. The one is being sure that what we write is correct and respects the requirement. And the other one is to actually make sure that what we wrote works and keep on working in the time. Because, well, what happens to me, well, it happened to me several times in my career, is that at some point something stopped working and I didn't really know why, even if the test passed. And I was like, yeah, why is that something that actually happens? And unfortunately, yes, but probably that was all my fault. So, another question that I usually get asked a lot from other people, because you have to know that I'm usually the one that advocates for testing, is, but is actually everything testable? I would love to say yes, everything is always testable no matter what. But probably my response would be more like yes, but you might need to do some work before. So don't take my word for granted. I prepared an example, which again is my word, but bear with me. So let's take a look to this code. Can you all read this code or something like that? Yeah. Thank you for the thumbs up. Okay, so what we have here, well, it's not testable. I mean, probably with some magic, we can get to test it, but no, because probably this is a very basic example, which doesn't really use anything. I mean, it's a fake dependency that just takes some data. But if we have a component that creates multiple objects and probably does work asynchronously and does the schedulers declared inside, yeah, no, that's definitely not going to work. So my first suggestion would be to move everything you can outside of your object and actually pass it as dependency. While this example is extremely easy, it can actually help remember this specific this specific notion. And while I'm sure that everyone in the room is already aware of this trick, because it's a trick that we all learned, there are moments in which I myself forget to do that. For instance, lately I was working on the new data store. And one of the parameters you can pass is actually coroutine scope. There is a default, which is the supervisor job and the IO dispatcher. But if your constructor basically doesn't take that in, but that means that it will be much more complicated to drive your tests with coroutines. It was the same with RxJava. So that's the first thing that I really want to highlight. Whatever is your dependency, don't build it yourself, but let someone else take care of that. Be it the dependency injection, be your own dependency injection, be whatever that can be. Just don't do that inside your class. Of course, there are moments in which you cannot avoid that. For instance, everything related to Android views. Unfortunately, we cannot access the activity constructor, or well, we could get the fragment constructor, but it would be much more complicated to pass the parameters. But for that, luckily, we already have tools that will take care of these specific aspects. But whenever you can, avoid declaring and building your dependencies inside your classes. So, moving on. So, what should I test? Well, the answer here is easy, right? Is everything. And that was the same thing that I personally thought until I spoke with someone that is way better than I am in most of the areas. And he told me something that I didn't really understand for a while. And what I didn't get at the very beginning is this sentence. Test the logic, not the code. Well, that's who told me. It's Fabio. He's a colleague of mine at the New York Times, and he's also a speaker. So what does this mean? If you think about it, it's not as simple as it sounds. At least it was not easy for me. Because if I'm testing the code, I'm testing the logic. And that's sort of true, but it's not really the same. Why it's not the same? Because you can write the same logic in several different ways. And most importantly, you actually might want to change the methods, the functions, or even the order of some calls inside the code. But that shouldn't impact the final logic. If your logic is, for instance, I have to sum A, B, and C, it doesn't matter if you do A plus B plus C or C plus B plus A or any combination of these two. So if you test the logic, you're sure that you're testing that A plus B plus C, it's always equal to whatever. If you test the code, you're actually testing the specific instructions that would perform this operation. But let's give an example because it's probably easier than my explanation. So let's switch to this example. What we're doing here is a very basic step of testing the code. So first, I'm not against mocks or stub or anything. They're all useful in different situations, but I really needed to use a mock here to prove my point. So what we're doing here is that when we invoke the fetch method in our repository, we're invoking the get data. That's simply. So we are making sure that this method is called. Then we can test the return type and whatever. That's not the point. But what we're doing is that we are testing the get data that we declared in the previous slides. What's the problem in here is that for some reasons, you need to add, you want to change your get data or you want to change how it's invoked, you need to change your test. And thus, well, you're basically somehow invalidating the results. Because if you need to change your test when you change your code, unless you change the logic, well, that is something that, well, it's complicated, or at least it's not optimal or as good as it could be. Of course, there will be moments in which you need to do that, but the majority of time, if you're testing the logic, this will not happen or should not happen. But to give an example that will show how we could actually test the logic in this specific scenario, it would be something closer to this. So instead of checking that we invoke the getData method, we grab the result that comes from the fetch, and we verify that this result it's the same that we expected. So far we covered two main topics. The first one is don't keep dependencies inside your object. Don't build them there, pass them from the outside. And it's something that I'm sure that everyone knows. And test the logic and not the code. That doesn't mean that you shouldn't use mock, stub, or any mocking library, because that's not the point. That just means don't check, for instance, that your methods are invoked, or don't check that your methods are only invoked once, or something like that. You might always find a different path so that you can test the logic and not the code. Okay. Now, let's dive deep into the types of tests that we have. So the first one is unit testing. So basically, we take a small part of our code that performs some logic and test around it. For instance, we can say that if we only tested the repository or the fetcher or whatever, just that small unit, well, that could be a unit test. And that's probably the easiest and faster way to test our code. And well, something that happened to me probably a while ago is finding the answer to this question the hard way. So is unit testing enough? Well, I don't have the answer for that, but I have a video that actually helps us a bit more. If I can make it go. Yeah. So we have a unit test that passes. We have another unit test that passes. But then we put them together and they don't really work. And that's not me. Those are my friends from Code with Italian. They have a Twitch channel in which they code every Wednesday and every Sunday. And they were nice to give me this video showing the difference. Well, not the difference, but why integration testing is important. So again, unit test is a very important piece, but it's not the only thing that we should rely on when we build our applications. So next topic is about integration testing. So when I was creating this talk, I wasn't really sure on how to define integration testing. I mean, if I try to define it myself, it will probably be I'm testing something from start to end and ensure that everything works. Probably correctly, that the logic is respected. It's complicated to give a definition. So I actually copied one from d.andre.com, which is much, much better than the one that I could come out with. Another thing that this definition implies is that you should take your feature from start to end, but that actually involves a few things that are usually the hardest to test. For instance, probably your entry point of the feature is a UI. then you probably need to access the network, and you have to deal with permissions, and you probably have to deal with a database or something like that. Or even you have to deal with multiple fragments, or nowadays probably with multiple composable. So I didn't really agree 100% with this approach, because my idea is always to separate everything that is UI from everything else. Mostly because it's easier for me to just test the pure code. So, what are my opinion on integration testing? Well, first of all, try to stay as far as possible away from Android specific dependencies. Why so? Because usually when you have Android dependencies, you have to run an Android test, which is great, but it's slower than running tests locally. What I mean is that if you can wrap things around interfaces and avoid passing direct dependencies, for instance, contexts, services, activities, or anything like that, inside your object. Or at least find the point where you don't need those anymore. Because at some point we need the context for everything. So you cannot really think about not having the context or not using the activities. Those objects are there for a reason. So we really need to use them. But whenever you can, try to draw a line and not separate it from, and separate your dependencies from the code that doesn't use it. An example, well, when you have shared preferences, you can hide them behind an interface, or actually you can use the shared preference interface and create your own stub. That is important because if you create your own stub, you can save everything in the memory and it will work in the same way. You don't really need to use the real shared preferences or anything like that. Of course, that doesn't work with everything, but most of the things can actually be replaced by their interfaces. Another point, which I think is really important, is try to test your flow from start to end. What does it mean in 2021? Well, we probably all use view models. And I personally think that I prefer view models over Android view models. Well, those are really easy to test. And you can really just grab your view model, perform all your tests by replacing everything that is flaky, for instance, network, because testing network is not easy, but we'll probably see it afterwards. And you might want to remove databases because accessing files is less than ideal when you have to test. And you don't depend on context, basically. Why I stress this out so much? Well, I found out that if I want to run my tests frequently, I need those tests to be as fast as possible. So I work on an app which is really big. We have probably hundreds of modules, well, probably not hundreds, but tens of modules. And it can take up to 7 to 8 minutes for a clean build. An incremental build usually takes from 1 to 2 minutes on an i9 with 64 gigs of RAM. If I have to run a test and wait 2 minutes, yeah, I'll be honest, I won't run it this often. Because what if my test is wrong? What if my code is not passing this test? So I'd rather avoid using Android tests as frequently as possible so that my JVM tests can actually run faster. Another thing that you might want to do is that whenever you cannot avoid context or anything that is really, really Android, you can always rely on Roboelectric. Compared to previous years, now with the version 4 released a couple of years ago, I guess, it's very, very easy to set it up and it's really super integrated. Why this is important? Because again, even if you need the Android framework, everything is running on your machine. And if it's running on your machine, it's going to be faster. And even if it's only 10 seconds or 30 seconds instead of 2 minutes, well, that is much, 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 much better. So now let's see how we could actually do some integration testing by using our friend fragment that we saw a few moments ago. So I hope this is readable. I had to use a smaller font than the previous code because space, but I walk you through this code. So what we do is declaring a fragment and injecting something. We don't care how we do that and how we get those, but we know that repository will be injected by someone, probably Hilt. Let's say that we use Hilt. What happens is that every time the fragment is resumed, we update the results from our repository and we bind the result to our view. That's a very normal use case. I mean, on all the applications that I've worked on, we could only reduce them to make a network request, get the data, parse the data, show them in the UI. Of course, with all the errors and everything, but that was mostly the things that we do on an app. Of course, every request is different and we have very different UIs, but this is an example that we should all relate to. So how can we test this? I know it's scary, it scares me, but there's a way. So we create some test doubles and inject them because we need a service, but we don't really want the service to go to the network. So we create a test double. We don't care what this test does, but we know that there will be someone that will replace our dependency in the fragment and basically replace it with our not networky dependency, and it will inject it automatically in the fragment. Then we create our test fragment, and then we run the test. I know this is a very bare bone test, but more or less it's what we will do. The problem with this is that these rely on Android tests. And again, it's going to be slower than JVM tests. That's a given. You have to compile for Android, you have to compile your app, you have to push the APK to your device, you have to push the test APK to your device, and then you have to run the test and wait for your app to start and everything. It's going to be slower. But again, if we instead check from the service on, well, this could be easily a test that stays in the test directory. So we talked a lot about networking, but we didn't really face it so far. So I think that in 2021, we have a lot of ways to do networking, but the true thing that we know for sure is that, well, network is unreliable. And that's something that I learned, especially when I worked, while I was working at the New York Times. So I'll tell you a quick story. Before the pandemic, because of course things slightly changed now, we noticed that the vast majority of our users were reading the app while commuting to work. The problem in New York is that commute is usually done underground. But underground, you don't really have a good network connection. Let's say that the vast majority of times, your phone is out of service and you only have Wi-Fi in some of the station. So for us, this was a huge deal. And well, it was a complicated problem to solve because you can say, yeah, I keep everything offline and the users will read it as well, will read it offline. So no big of a deal. Well, more or less, because for the type of content that the application provides, we want that content to always be fresh. But if it's offline, we can't really guarantee that that's fresh content. So of course, we had to, well, find a solution that will guarantee us that we'll try to fetch the freshest content or fall back with the default one in case the network was unavailable. So while this story was completely out of topic for this talk, well, I needed it to show how I learned that lesson. Basically, you should never rely on network because even if you're not testing in a subway, well, things that can go wrong are a lot. For instance, your network is congested and you don't get the response in time, the test time's out, and you have a failure. Or, well, for some reasons, someone cut the cable and you don't have internet. I don't know if you all remember, but it happened a while ago that a bunch of people were without internet because of an accident that happened in a big data center here in Europe. It was probably 10 years ago, and nowadays it won't happen. But it happened something like that to me a couple of weeks ago that someone, while they were covering the streets again, someone cut the phone cable. It was a fun couple of days. But again, now we established that network is unreliable. So I'd like to suggest two approaches that I personally love when we talk about networking. So the first one is using retrofit plus OKHTTP plus mock web server. And the other one is using KTOR and mock engine. Of course, there are many other ways of doing so. The first thing that comes to my mind is using GraphQL. But, well, GraphQL under the hood can use OKHTTP, so it really is the same. So let's switch to the very first of these examples. So here is a common declaration of retrofit. But it actually hides a small trick that we already saw earlier, well, that will make it impossible to test as it is now. So the first thing that you have to see is that URL should always come from the outside. Whenever you build your retrofit client, you should not hardcode this URL there, but instead rely on something like that. Okay, that's the first step to test retrofit. The second step is the actual test. So we need the mock web server. And we need to enqueue all our responses that we want to provide so that every time we perform a test, it will give us the following response. Another approach would be to actually have a sort of way to pilot the mock server so that it responds as you expect in a specific test. Then you start the test, and then you grab the server URL. This is why you want retrofit to take the URL from the outside, because once you create the server, you can get the URL, pass it to your retrofit, and you're ready to test everything that actually interacts with your API. One thing to remember is that you should always shut down your server when you're done. So called server.stop. And the same goes with actually Ktor. So this is slightly different because, well, it took me a moment to realize how we should test this, because for how Ktor works, well, you don't really pass a base address. So it was slightly more complicated, but it's the same concept after all. What you need to pass from the outside is the engine. So this one should always come from the outside, because that Android there is the engine factory or the engine that Ktor is going to use to make network requests. And if you can extract these and pass it from the outside, well, it will make your life much, much easier when you're trying to create a mock engine. And, well, this is much simpler because you can define how we should respond based on every request. So you inspect the request and check the response. And then you pass this mock engine instead of your Android. But for doing so, you need your Android engine to come from the outside. Okay, now probably the most complicated part is UI testing, which is sometimes quite painful on Android. But we can deal with this. So when we talk about unit testing, nowadays, the first thing that comes to my mind is using Espresso. Well, of course, Espresso needs to be an Android test, and you can probably test most of the things with Roboelectric as well, but, well, you need your UI. There's no other way around that. You need your app. And, well, testing with Espresso is not easy and is not complicated. It really depends on how you approach the problem. But, well, let's see a very bare-bone test on Espresso and try to understand how it works. So the first thing you want to do is creating an activity scenario so that you can pilot your activity step by step. What happens there is that you can decide to launch your activity or a fragment and drive its state. So you can say, okay, now it started, now it's resumed, now it's stopped, now it's paused, now it's destroyed. And based on that, you can perform all your assertions. Then with this syntax, what you do in your test is taking a view that has a very specific ID. So you're going to use the same IDs that you use in your layout, and you perform some actions. In this case, what we do is type in a text, and then we close the software keyboard. Then we find again the button, and we click on it. And we test that what we expect that will happen actually happens. So we use the check method and see if it matches the text you expect in the target view. As you can all notice, well, it's not the easiest of the approaches, and it takes a while to write good Espresso tests. To be honest, well, this is the top of the pyramid, and it's probably the test that I use the least for many reasons. One is that it's complicated, and I personally find it really hard to run Espresso test every time I change something. But this is how you want to do it. There are a lot of things you can do with Espresso and the automator, but it's a totally other journey. It would actually need a talk on its own, more than an overview on all the kinds of testing. But now to the topic that I really love the most, which is, of course, testing on Jetpack Compose. So first, I show you this simple UI. So basically, when you click, it tells the state and tell you how many times you clicked. Well, this is really the first Compose example. But let's take a look to our UI. So what we're doing here is creating a compose. As you can notice, I'm not hosting the state. So the state is stored in the composable with a purpose. So we create a column that has a button that every time we click, will increase the number of clicks. And if the clicks are more than 0, then we create a text and we show this text. So very easy, a very easy UI. But to test this, well, it's actually possible. I mean, we don't need to do anything. This code like that is really easily testable. And how you will do that? Well, you first create a compose rule that will let you basically draw your composables. And then you use the semantics. So the same thing that you would use for accessibility to find a composable that we tagged with the tag clicks. And then we verify this does not exist. So what does this test actually test? Well, it tests that we don't have our view. We don't want our view to show, so it should not be there. And we could do that with 3 lines of code. But now let's see that how we can test that our UI actually refreshes, because, well, now it's only the initial state. We really want to see if it actually works. So once again, we create a compose rule. We use it to set the content and push our simple UI. And then what we do is basically finding the node with the text, because you can search with both text and the accessibility tag or the testing tag. We find this node and we perform a click. And then we check that when we clicked, well, we now have the text that we created, and its text actually is what we expect. So while we are really barely testing the logic here, it makes sense, because if you change your UI, you want to make sure that actually you change the text. And that's, I guess, the only exception. And why so? Because, well, this test will tell you that your UI is always working as you expect, unless you change it. But unfortunately, there's no other way around. If you change your UI, you are going to change your tests. Okay, now for the very last question that I have been asked multiple times, how can I start testing? Well, that's the hardest part. Well, you just need to start to try test. That's the only way. It's a place where practice helps you a lot. I can tell you that it will make you perfect, because I didn't reach that stage yet. If I ever get there, I'll let you know. But definitely it helps. So don't be scared. Try always to test whatever you write for your own good, because it always helps you when you're touching something else and something breaks. And with that, I think we are in time. So thank you all for listening to what I had to say. And if you have any questions, there should be mics. At least I see mics in the room. And thank you again.